Okay, so number 24, it says find the difference quotient. And I don't know if you guys remember the difference quotient, but it was kind of intense. Okay, so the difference quotient works like this. For a particular function, okay, let's say a function went like this. We could figure out, like, let's say if we had an x value, okay, if we had an x value like this, we'll just call it a, okay, we could figure out what the y value was by finding the function evaluated at a. Do you guys remember that? That's an a. Okay, so that means that this ordered pair that's right here would be the x value a, and then this y value, which is the function evaluated at a. That's what that ordered pair is right there. Okay, now in order for us to find the difference quotient, it's basically finding the slope. So we want to know from this point to, let's say, this point over here, what is the slope between these two guys? So from here to here, what's the slope, right? Okay, so how do we figure out what this is? Well, this is some distance away from a. We don't know how far, but it's some distance away from a. So let's say that this can be a plus h, okay? A plus some distance h right here. All right, now if this is a plus h, over here the y value is going to be the function evaluated at a plus h. That means that you'd have to substitute that in, okay? So the ordered pair for this guy would be a plus h, that'd be the x value, and then the y value would be the function evaluated at a plus h. Okay? That makes sense? Now how do we find the slope between 2 points? There's a formula, right? The formula for that is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So all we got to do is just take the one that's further away, okay, and subtract it from this one, and then this one minus that one. Okay, so let's try that. So if I take that f of a plus h, and I subtract it from this guy right here, which is the f of a, and then divide that by the a plus h minus the a. So we can see right here that a minus a, those are just going to cancel, and then this is considered the difference quotient. This is the difference quotient right here. Okay? So what you have to do is evaluate the function with this in there, evaluate the function with this in there, and then divide it all by this random variable h. Okay? So here's the function of x, which is like that. And so first what we're going to do is we're going to find the function evaluated at a. So that means I'm just going to take this, and everywhere I see an x, I'm going to put an a. So if I have 5x, so x is just going to be an a. So 5a minus 2. That's that one. That's what's going to go right there. Now next I'm going to find the function evaluated at a plus h. Okay? So everywhere I see an x, I'm going to put a plus h. So it's going to be 5 times a plus h minus 2. All I'm going to do is just distribute real quick, and then that's going to be 5a plus 5h minus 2. Okay, so that's what that one equals. So now we're going to substitute that in. So this portion right here, oh, that needs to be bigger. Let's go like this. I'm going to put that right here. So this is going to be 5a plus 5h minus 2. Then minus, this is the minus right here, okay, this guy right here. Okay, and then the f of a, which is 5a minus 2. Now I have to put this in parentheses because I'm subtracting a binomial, so that's 5a minus 2. So basically what's going to happen is this is going to change the sign of everything here. So we'll just make that a positive, and then this is minus, and this is plus. Okay, now all of that is being divided by h. Okay, now let's look real quick. If this is a negative 5a and this is a positive 5a, that's going to end up canceling. Okay, and if this is a positive 2 and this is a negative 2, that's going to end up canceling. So really what I'm looking at is 5h over h. Then the h's cancel, and we're left with 5. So the answer for this one is just going to be 5. Now you guys want to know something crazy? Something crazy is that, remember, finding the difference quotient is just basically finding the slope. This is a linear equation. This is the m, which means this is the slope. Okay? So the answer is staring at you whenever it's a linear equation. Now, it's not always going to be that easy. If it had a square, if it's a quadratic, it's a lot more difficult. So watch out for that because, but I mean, this is how you do it in a nutshell, okay? So let's do the next two. These ones are kind of tricky because it says find all the vertical, horizontal asymptotes and holes. Okay, so we were dealing with this, and I don't know why, but all my parentheses are gone. Okay, so that's what that should look like. Now, first what you're going to find is these vertical asymptotes, and a vertical asymptote is just anything that makes the denominator 0. Okay, so this one right here, if I put in a -3, that's going to make that 0. 0 times this will make it 0. Okay, and remember 0 in the denominator, that is bad. We don't want that. Okay, so -3 is going to be one of them, and then over here this is going to be 1. All right. Now, if anything cancels out with the numerator, like for example this x plus 3 and this x plus 3, if that cancels out, then that means that this one right here, that becomes the whole. So it's no longer a vertical asymptote, but it's going to be a whole now. Okay, so our whole is going to be when x equals -3. Okay, and this one right here, this is when x equals 1. So to give a sort of visual what's going on here is that a vertical asymptote is obviously vertical, and at 1 it's going to be going like this, right? Okay, and however the graph is going, once it gets to -3, like it's gonna continue, but then there's gonna be like this thing that looks something like that. Okay, so there's gonna be this hole, and so that's how we find that. Now a horizontal asymptote we can find by first determining what the highest degree is up at the top and what's the highest degree at the bottom. Okay, so if we were to multiply this, this would be 2x times this, so our leading term would be 2x up top. Now down here this would be x times x, so I'm sorry, this should be squared, and then x times x, that's going to be x squared. Okay, now since they're the same, okay, if the degree on the bottom is the same as the degree on the top, that means that the horizontal asymptote is going to be the fraction of the coefficients. I don't know if you guys remember that, but horizontal asymptote, the fraction of the coefficients, so it's 2 over 1, so it's just going to be when y equals 2. Okay, so when y equals 2, there's going to be this like crazy sideways asymptote that goes out like that. Now, when it comes to horizontal asymptotes, this is how it works. Okay, if they're the same, okay, so if they're the same, then it's going to be the fraction, okay, of whatever so it's going to be a over b, okay, so whatever the leading terms are, so we'll just say leading terms, okay, leading terms, so it's the coefficients, that's what it's going to be. Now, if the bottom is bigger, let's say that this was a 12 or something, okay, if it's got a big bottom, okay, the bottom bigger, then that means that your horizontal asymptote is just going to be when y equals 0. So it's just going to be at 0. Now, if the top is bigger, okay, if the top is bigger, then it's not a horizontal asymptote, excuse me, but now it's called a slant asymptote. Remember the essay? Okay, so slant asymptote's kind of weird. This is what you do. That one's not one. Okay, so watch. X, let's say that this is x squared plus 2x minus 3, and then down here has a lower degree like x. Okay, so all you're going to do here in this case is you're just going to divide, well, let's make it like this. You're going to divide this by that. Now, how do we divide this by that? So let me write that on the side. Here, in order to do that, you're going to divide. Okay? Well, I would just use synthetic division. Remember, we take the opposite, so that's going to be positive 2, and then you have 1, 2, and negative 3. So you bring down the 1, he gets a free pass, and then that's a 2, and that becomes a 4, and then this times that is 8. Okay, now the remainder you're not looking at, okay? But this right here is your slant asymptote equation. Okay, so that means it's going to be 1x plus 4. Okay, so the slant asymptote would be y equals x plus 4. That's how you find the slant. Kind of confusing, and there's a lot to remember for those, but that's how you do it. Okay, so number 26, I think you guys should try that on your own, and let's move on to this next one. We'll do 27 and then take a break there. All right, so 27, it says factor and then simplify. And before you guys look at this, I want you to watch something. if I had x squared plus like 2x or something like that, do you know how to factor this? Of course we do, because we mastered Algebra 2. Well, if I look at this and I say, okay, well, there's a common factor of x in both of these terms, so I'm going to pull out the x, and then what's left over is an x plus 2, okay? And then, like, if I needed to solve it, it would be equal to 0, right? And then I would set each of these equal to 0. So you're going to do that in a little bit. But this one, it just says to factor and simplify if you can. So do you see a common term, or a factor, I mean, in each of these terms? Yeah, they both have a tangent squared, right? So if I pull out a tangent squared, okay, if that comes out, then this is just going to be a 1, and then I have minus sine squared x. Now, I've seen this somewhere before. You know, back at the very beginning of this test, like question number 1, we learned that one of the identities is that if you had sine squared x plus cosine squared x, that equals 1. So if that's the case, is there a way that I can make this somehow... Well, see how the 1 and then the sine are together? So if I subtract 1 from, or excuse me, sine from either side, let me make this blue. If I subtract sine over here, okay, then that's gone, and then I'm left with cosine squared x equals 1 minus sine squared x. So do you guys see what's going on here? This right here equals cosine squared. So that means that I can take this and I can replace it, see, simplify it, and say that this is the same thing as tangent squared x times cosine squared x. That's a multiplication, okay? Times. All right, now let's kind of keep going with this. We know that tangent is the same as sine over cosine. And then this is cosine, so this is cosine squared x over 1. So you guys see how these can cancel out? So cosines are gone, and so we're left with just sine squared x. Okay, so that would be the answer for that one there.